This is Stuart from the Planning Analytics team. In this video, I'm going to demonstrate how to use the Cube Viewer from Planning Analytics Workspace. Keep in mind this Cube Viewer is available in Planning Analytics Workspace books, in the Modeling Workbench, and in Planning Analytics for Excel. For the purposes of this video, I'm going to use a book. So let's go ahead and create a new book in Workspace. And the first thing we'll do in this book is we'll pull in a view from the TM1 database. We'll use our planning sample database. We'll expand the list of cubes. We'll expand the list of views under one of our cubes, and then we can simply drag in one of the existing views. We can either drag and drop this, or we do have an option to right-click and say Add View. This adds the view from the TM1 database to the book as a Cube Viewer widget. So what we're looking at here is our Cube Viewer inside of a book. Now keep in mind, at this point, this Cube Viewer and the Cube View in it is not the same as the Cube View in the TM1 server. If this view in the TM1 server was deleted, this view in the book would continue to work. We've simply copied the structure of this cube in the book, which is actually a native view, and represent it as a view within the Cube View widget in Planning Analytics Workspace. It's pretty much detached from the view in TM1 server at this point. I say pretty much because this view may reference named subsets in the TM1 server, and if those subsets happen to change or were deleted, we would see an impact on the Cube View, different members being displayed, and so forth. However, we do support a bit of a fallback logic, so if a subset that the view was referencing happened to be deleted or was changed to show no members, the view here would still work mostly as expected. So at this point, we know that the view in the Planning Analytics Workspace book was based on the Cube View in the TM1 server, but it's now a different view. If we wanted to see what view this came from in the TM1 server, there is a way to access that information. We have an option here for context information. And when we enable this, we see the following details show up in the overview area up at the top left. The database that the view came from, the name of the cube that the view was sourced from, and the original name of the view. Now keep in mind, I can save this view back to the TM1 server. We do have a button up here, which will save the view. And I have options to save it to the server, which means to save it to TM1, and it'll show up under the list of views here as an MDX view. Or I can save it independently as a view in Planning Analytics Workspace. You may want to save this view to the TM1 server if it was going to be leveraged by other clients that weren't aware of Workspace views. Also, you may want to save it to the server if this view is going to be the data source for a turbo integrator process. If we save the view in Workspace, it saves not just the view, but all the other format information and configuration information that's specific to the widget. Okay, so we should probably understand a few different areas of the Cube Viewer widget in Workspace. I'll go ahead and minimize the database tree. The first area we want to take a look at is the overview area. That's the very top part of the Workspace Cube Viewer widget, which shows the details of the view, as well as some options up at the top right. And then the hierarchies. The hierarchies are displayed on three different axes: the row axis, the column axis, and the context axis. This is also commonly referred to as the filtering axis or the slicing axis. If I didn't know which axis was which, we could also enable that information. We have an option here for section headers, right? So I can see context, row, and column now, or we could enable the icons. We can choose one without the other. If we want to save a bit of space in the Cube Viewer, we can show the icons only. If we need to provide more information to the user about what is what, then we can enable the section headers that actually gives them the string. The other thing that we can enable or disable here is the hierarchy names option. So if I enable this, I can now see on what we call the selector tiles, the names of the different hierarchies that are positioned on the view. If I don't want to enable the hierarchy names, because I want to save a bit of vertical space here, I can disable them. And we'll notice that when we hover over, we have a fairly informative tooltip that shows us the name of the dimension, the hierarchy within the dimension, the current set that's being used, if a set is being used, and the currently selected member. For rows and columns, we see the dimension, the hierarchy, and the set. Of course, for rows and columns, we don't show the member because it could be one or more members being displayed. Whereas the context axis, we need to pick one member or one pseudo member to display. The other areas of the Cube Viewer are the data area. This is the grid where we actually see the numbers that are stored in TM1. And then we can also see the row header along the left-hand side, and the column header along the top of the data area. So the independent areas that we sometimes refer to in the Cube Viewer are the overview area with the selector tiles, the row header and the column header, and then the data area. Now, of course, it's possible to have multiple hierarchies being displayed in the rows or columns. We can do this by simply dragging and dropping the selector tile from the context area to the row area. Note that when I drag and drop these, I can do before, after, or between the other hierarchies. I can also manipulate the order that these hierarchies appear in. Now notice, because I don't have enough horizontal space here, and if I make this a little bit larger, we may see the hierarchy show up. But if we don't have enough horizontal space, the hierarchies will eventually fall off and we'll see this black box. This is a bit of an overflow area where we can see hierarchies that couldn't be fit. It's definitely possible to drag and drop these from the overflow area to other places in the Cube Viewer overview. Right, so here we could see grabbing the department's dimension or department's hierarchy and then placing it back up on the context axis. We can also rearrange the order on the context axis, right? Of course, this doesn't have any effect on the data that we see. And we could also pull hierarchies from the context axis down to the rows. And then of course we can swap. In order to swap, we simply have to drag over top of one of these. So if I drag the plan department hierarchy over top of the plan time hierarchy, we'll see they simply get swapped. The same thing works if we drag from one axis to another. So if I drag the plan version hierarchy from the context axis on top of the time hierarchy in the column axis, we can see that they simply swap. Let's swap it back. And then we'll change this so we pull all departments onto the context axis. It's also possible to move the selector tiles to other axes of the Cube Viewer without dragging and dropping. Let's say I wanted to move this plan department to the column axis. I can click on the overflow menu, and then I have other move options, and I can say simply move it to the column. If I wanted to move the selector tile to a different position within the same axis, again, I could go to other move options and simply say to move it left. Now we can see plan departments, and our departments are the first hierarchy in the column axis of our cube view. We can also remove hierarchies from our view. In order to do this, we pick one of our hierarchies, go to the overflow menu, look at the hierarchy option, and select remove. The hierarchy has now been removed from the query state. However, we can still see this hierarchy in the bench. The bench can be found up at the top right of the cube viewer with this eye icon. When we click this icon, we can actually see all of the hierarchies in the bench. Note that we actually have two hierarchies in the bench: the plan department hierarchy, which we just moved to the bench, and also the sandbox hierarchy. The sandbox hierarchy exists here because the sandbox as a dimension feature has been enabled. But by default, we don't place the sandbox hierarchy on the view. Now, the other thing to notice here is that the plan department hierarchy has selected a specific member. The member that it's selected is the default member of the hierarchy. This query is actually the same as if we had this hierarchy on the context axis set to this member. So keep in mind, when a hierarchy has been removed, you may not see that hierarchy in the query state. And if we examine the MDX, we will not see the plan department dimension or plan department hierarchy in the MDX statement. But that is the exact same as if this hierarchy was on the context axis set to the default member. If we look now, we can see the plan department hierarchy is referenced with the default member, but we'll notice that the data and the query state is the exact same underneath. Let's examine a few other features in the Cube Viewer. For starters, we have a button to collapse and expand the overview area. With the overview area collapsed, we still see the buttons up at the top right, plus the context information, but the hierarchies on the Cube Viewer are hidden. This may be useful if you're trying to provide a static Cube Viewer where the user is going to only interact with data and not move hierarchies to different axes of the view. If we wanted to hide the cube view overview altogether, we have a button that's available in the toolbar to do that. Notice that this toolbar is only available when the cube view widget is selected, regardless of being in edit mode or non-edit mode. So if I click outside of the cube viewer, just on the canvas of the book, we can see that we only see the buttons for the workspace book. Once I select the cube viewer, we see the buttons for the workspace book, plus all the toolbar buttons for the cube viewer, one of which is the option to show and hide the overview area completely. Finally, the last button up at the top right of the cube viewer is the button to show the cube in view in the model tree. Now, if the model tree is not expanded, we actually don't see anything happen when we click this. However, if we expand the model tree, we can see that the model has been expanded, the cubes have been expanded, we've selected the cube that this view is sourced from, and we've selected the source view. I'll collapse the model tree one more time, including the objects in the model tree, and I'll click the button one more time just to show how this feature can be used with the model tree open. Right? It simply selects the target view, or the source view, rather, that this view came from the tree on the left-hand side. We'll close the model tree, and let's start to examine some of the other buttons in the Cube View toolbar. Now again, notice that if we click off of the Cube View widget, we see that the workspace book itself still has some buttons. One of the first buttons that we want to examine is this button here, which is the data rollback button. Although this button isn't specific to the Cube Viewer, it does impact the Cube Viewer. So let's go ahead and we'll select the Cube View, and then we'll enter some data into a cell. Once we enter data into the cell, we can see that the data rollback button becomes enabled. And if we click it, it'll roll back the data change. Now this button is common to a few different widgets. The Cube Viewer is just one of those widgets. So for example, you could have a single cell widget that supports data entry, and you may want to roll back as well. For that reason, we have a single button for data rollback, regardless of the widget. The first button that truly belongs to the Cube Viewer is the export button. The export exports the data that we're looking at to an Excel file. In fact, it exports more than just the data that we're looking at. It exports the data that we're looking at in the Cube Viewer, plus any other data that's based on the view. Now it's important to understand that our Cube Viewer supports pagination. So you can see that as I scroll, it appears that data is blank, and then data is being loaded. That's because the data isn't known at the time I'm scrolling. When I scroll, a request is made to the TM1 server to pull more data for the view I am looking at. This is what allows us to load small amounts of data and to keep the Cube Viewer very quick and responsive. The export feature has to export not just the data that we're looking at on the screen, but all data that's defined by this view. So keep in mind that when we use this export feature to export to a CSV file or an Excel file, that it may take longer to run than it does to take the Cube Viewer to normally render. This is expected in most cases. The other thing we'll notice in this export feature is that we can burst, right? So in this case, we're presented with a few hierarchies. Notice that these are all the same hierarchies that are currently on the context axis of the Cube Viewer. So our plan version, plan source, plan exchange. If we select one of these, it'll actually create a different version of the data export for each of the members currently configured in the set that's being used. So when we see all versions 5 and plan source 4, if we go and look at these dropdowns, we'll see that there's indeed 5 members here and 4 members here. If we change this to have less members, which we can do by going into the set editor, we'll pick, let's say, 2 members and say replace. When we do an export now, we'll see that we only have 2 members to choose from. Again, if we pick nothing here, we're just going to export the data that we're currently looking at. If we pick one of these, we're going to get different slices for each selection. If we pick multiple, we can see that we can get up to 10 slices because we have 5 versions multiplied by 2 different sources. We have choices whether we want this to be all one single Excel file or multiple Excel files. So if we click export, the export process will run. Again, it can take a bit of time to run. In the back end, it's just generating an Excel file or a bunch of different Excel files with different sets of data. And of course, we get the option to actually download the file here. The button to the right of export is the snap commands button. We're going to skip snap commands for now, and maybe we'll revisit this in a later video. After snap commands, we have the save button. The save button has a few options: save view and save view as, save the view to the Planning Analytics Workspace content store. Keep in mind that this saves both the view, including the MDX definition of the view, but also includes any formatting and configuration options for the Cube viewer. If we save to server, the view is being saved back to TM1. This is useful if the view needs to be used as the data source for the Turbo Integrator process, or used with some other client tool that's not aware of views saved in Planning Analytics Workspace. Keep in mind that when we save to server, we're really only saving the MDX definition, so any of the formatting and configuration features available for the Cube viewer are lost at that point. After the save button, we have a format button. The format button will format all the data that we're looking at in the Cube viewer. So assuming this is all accounting or currency data, we could pick accounting or currency here, and then we'd see everything show up with dollar signs. We do have other formatting features that can format specific rows and columns. This simply formats all the data that we're looking at. If we don't want to use a format from Planning Analytics Workspace, we can use the native format from TM1. This is done by saying use database formatting. And in this case, we get the format that's actually provided by the TM1 database for this view. Note that we have a couple other options in here, such as text wrap options, which only apply to string cells within the view. But we can choose whether that data is wrapped with or without support for line breaks. The next button after the format options is the swap rows and column button. Like the name suggests, this simply swaps the hierarchies that are in the row axis with the hierarchies that are in the column axis. It's very similar to the drag and drop or the move hierarchies feature that we looked at before, but it's a one-click action to swap rows and columns only. The next button is our zero suppress button. Note that we can suppress rows or columns independently, or we can choose to suppress both at the same time or none. The next button is our MDX button. The MDX button shows the MDX statement that's being generated by Workspace. Keep in mind that all the other gestures that are performed against the Cube viewer are mostly generating MDX or modifying this MDX. So this MDX will change as we drag and drop hierarchies to different positions, as we add filters and sorts, and so forth. The next button is our refresh button. This button would be used if we want an updated set of data. So because the backend database is TM1 and multiple users could be using TM1 or processes could be running in the background, the data may change over time. If we've been looking at this view for a while and we simply want an updated version of this view, we can click the refresh button and we'll request a new set of data from the view to the TM1 server. The next button configures when a refresh automatically happens. And we have two options in here. One option to change or refresh the view after each context change, and one option to defer leaf data change. Before I show this, I'm going to add the hierarchy, plan department, back to the view, and I'm going to make sure that we're looking at the view at a leaf level, or at least looking at some leaf level data here. In order to do that, we'll pick a leaf level business unit. And now we can see that some data is no longer in bold, which means it's leaf level data. We have the deferred leaf data change option enabled. With this option enabled, we'll notice that when we enter a new value, we'll change 1400 to 1500, the value is green. We can enter multiple values here, and we can see this data remaining green. At this point, the data change has actually been sent to the TM1 server. So keep in mind that even though it's green here, other users who are looking at this view of data and these same cells may see the updated values already in black. We've simply deferred a recalculation of the view for ourselves on entering leaf data. If we click the refresh button, we can see the data goes from green to black. And we can also see the impact of the numbers that we entered on consolidations and roll calculated values. If we disable this option, we can see that the change happens right away. So if I change the value back to 1400 and hit enter, the impact is immediate. We see the change in the consolidation and any other rule-derived cells that are basing their value on this cell that I've updated. So if we think about this, it may be very useful to defer leaf data change on larger cube views where a lot of data is entered, but it may be very useful to not defer leaf data change on smaller views where we need to see the impact of the entry immediately. The option to refresh after each context change allows us to make changes to the structure of the view without actually having a recalculation. So for example, if I pull this hierarchy from the context axis to the column axis, you can see that there's no data here, right? That's because I've deferred the refresh. I would only do this if I wanted to make a few changes to the structure of the view. Let's say pull a second hierarchy down to the row axis or column axis. And if I knew that these changes were expensive to recalculate each time. This way, instead of recalculating once on each change to the structure of the view, I can make all the changes to the structure of my view and then click the recalculate button. So this option would be typically useful only when we need to make a bunch of changes to the structure of the view and we don't want to wait for expensive recalculations.